All right, so we're dealing with a ratio problem where we're trying to figure out the scale factor of real-life objects to kind of models. And one of the classic examples that we use in algebra is regular tennis courts to table tennis courts or ping pong tables. So in this question 31, it says, in table tennis, the table is a rectangle 9 feet long and 5 feet wide. A tennis court is 78 feet long and 36 feet wide. Are the two surfaces similar? So what it's asking is the model the same dimensions as the real thing? Or is the scale factor, the ratio between the length and the width of the two different surfaces similar? Are they the same ratio? So what we need to find is if we can determine if the table tennis length is the table tennis length and the table tennis length and the tennis court length are the same ratio as the table tennis width and the tennis court width. If those are the same number, then they're similar. Figures. So here's how we do it. Let's plug in the TTL, or the table tennis length, which is 9 feet long, and then we're going to plug in the tennis court length, which is 78 feet long. So 9 over 78. I can reduce that by 3, both top and bottom, and I get 3 over 26. So that's the smallest I can reduce the fraction. Let's see what I get for the width of both the table tennis and the tennis court. So the width of the table tennis is 5 feet, and the width of the tennis court is 36 feet. Now 5 over 36 I can't reduce, so I can't compare the fractions, but one thing I can compare is their decimals. So if I divide 5 by 36, I'm going to get 0.1389. If I divide 3 by 26, I'm going to get 0.1154. So comparing those two decimals, they're not the same. So to answer the question, are the two surfaces similar? The answer is no, because the ratios don't match up. The two different ratios between the lengths and the widths of the similar surfaces don't match. So they are not similar surfaces. Now obviously, where do we get table tennis from? The tennis court. But the numbers don't match up. So they're not similar. So on number 32, it's kind of another example here, a digital projector. So you're preparing a presentation to be projected on the wall of a classroom. The computer screen is 13.25 inches wide and 10.6 inches high, and the projected image on the wall is 53 inches wide and 42.4 inches high. So are the two shapes similar? So here's a diagram I'm going to make. There we go. And so it says that for the blue, the computer screen, it is 13.25 inches wide and 10.6 inches high. For the projection on the wall, it's 53 wide and 42.4 inches tall. So again, we're going to do the same thing we did before. We're going to compare the widths and the heights to see if they are similar. So I'm going to put 10.6 over 42.4, the two heights, and 13.25 and 53, the two widths. And if we divide 10.6 by 42.4, we're going to get 0.25. If we divide 13.25 by 53, we're also going to get 0.25. So what does that tell me? That means they are similar because the ratios are the same. So what they want to know is, what is the scale factor? So from the computer screen to the projected image. So the computer screen is 0.25 to 1, meaning the computer screen is a fourth of the size of the projected image.